You want to start with some question stuff?
Yeah.
And we'll take some questions from you guys, and I'll present you with some options about what to do next. And Victoria.
So, like, for the review, like, by the end, where it's, like, just evaluate the indefinite interval, like, how do you know when to use substitution and when not to use it?
Okay. So some of them you can do without use substitution, some of them you can't. So when I see like a function inside of a function, like 13 is a classic use substitution problem, where I have the 1 plus 2 theta inside like the 2 over the 2/3 power. Or like this one where I have x squared plus 1 underneath a square root. Or even like 12 where I have that 1 plus cosine squared, where I'm probably going to just use cosine on that one, and aim for like the tan inverse antiderivative. But like anytime I see like, I don't know how to do the quotient of 2 different kinds of functions without doing a u substitution, right? Like can't do that, can't divide those things to get something simpler. Like the one above, I can FOIL this out and then divide and get it just like 3 things added together, which I'm like, okay, I can deal with that without having to do u substitution. But like 12, I can't because I have the quotient of 2 things. 13, I can't because I have like a quotient again. Here, 14, I can't because I have a product. Like I don't know how to do the antiderivatives for quotients and products and like compositions.
Okay.
The hope is that I can u sub that and get it to work. Now, u sub is not like a universal fix-all. It's not like the skeleton key for everything. But if you can't do it directly, at this point, it's going to be a u sub problem. And we'll look at some other, in the next chapter too. Well, maybe not next chapter, but in the future, we'll look at some other methods that we can use to kind of like skirt around that problem. Does that?
Yeah,
that's like a high level question rather than like a super specific nuts and boltsy question, but I'm happy to do that. Paul, do you have a hand?
Yeah, I feel kind of dumb for asking this one, but can you go over number 4? So I kind of like forgot.
On the review?
Yeah.
Sure. So my key here is that I noticed that.
For number 4.
Oh, 4. All right. So let me just whatever. Okay. So it asks for a left Riemann sum. So I'm going to make an interval from 23 to 36. I'll make an interval from 36 to 48. And I'll make an interval from 48 to 60. Right? The delta x is 13, 14, and 12. So those are like the widths of my rectangles. And because it asks for a left Riemann sum, the heights are going to be the left end, or going to come from the left endpoint of the interval. So 9.8. And then the left endpoint of 36 and 48 is the 36, so 10.1. And then from 48, which is 9.5. So the integral of r of t from 0 to 60 dt is going to be the 3.75, which is up to 23. We're told we did that much. And then 13 times 9.8, but we have a units issue here, right? Because we have minutes and then per hour. So I'm just going to 13 over 60 to turn that into hours.
I think that's what I didn't get. I was like looking at the key and I was like, why is it over 60?
Yeah, so just a units issue there.
that makes more sense. Thank you.
Yeah, so this is like that's the integral from 0 to 23 r of t dt, and then the integral from like from 23 to 36 r of t dt, etc. Right? Each one of those rectangles is an approximation for a rectangle or for an integral, and that's it. So just the thing you care about is the left Riemann sum tells you which endpoint to use, or the height for which endpoint. And then this piece here told you what happened prior to where the table started.
So it says in the problem that you use 3 sub-intervals.
Mm-hmm.
Are your 3 sub-intervals your 23 to 36?
Yeah. Yep, those are my 3 sub-intervals.
But if it was the right Riemann sum, it would be the last 3.
So yeah, then this one would be 10.1, this one would be 9.5, and this one would be 10.6 if it was right. But that's the only material change that would happen, right? From left or right, it doesn't. And those are the only 2 things I could ask given a table like this. I mean, I could if we did like, you'd need like 6 boxes though, so that you could do like, that would be 1 subinterval, and then like that could be the next subinterval, and you'd have to have, with only 4 data points, not really. You know what I mean? But Victoria? From the same thing? Okay. I'm going to erase this out of here because, well, we already have a key and this is supposed to be the blank one. Ugh. There we go. 7. Okay. So what I want to do is we are looking for the integral from 8 to -3 of f of x dx. I know that's the same thing as the integral from -3 to, or from, is the same thing as negative, the integral from -3 to 8, right? Which is the integral from -3, negative f of x dx plus the integral from okay, sorry. So that's that, sorry. And then this I'm going to break up into -3 to 2, and then 2 to 8. So still have that negative sign. So -3 to 2, and then 2 to 8. And I can do that because the end point for one is the start point of the next.
Wouldn't it, if like you switch like that 8 to 2, wouldn't that be negative?
Well, I'm going to need to do that still in a second. So I'm not done, right? I'm just explaining what I've done so far. So if I distribute that negative through, I have this. And then this guy we have, right, as is, right? So this is just negative natural log of whatever, 12 minus 7. And then this piece, though, we don't have. We have from 8 to 2. So we'll flip it again and nix the negative sign, right? And then we can drop in what we had there, which is 6 minus log 4.
Like, why did
Go ahead.
why did you like flip it back after you
Well, because I need to use this substitution here, right? I didn't have that yet anywhere.
But if you flip it, then wouldn't that like thing that's equal to is negative?
So if I flip it, the thing, yeah, well, it was negative to start with. That's why I made it positive. Right? Negative, negative is positive. Going from like this guy to this guy, it was negative. So when I flipped it, it became positive.
Because it was already negative.
Yeah, negative of a negative is a positive, right?
So if you keep flipping, it's going to be like another negative,
Yeah.
even if 2 to 8 is not negative.
I mean, yeah, I think so. I'm not entirely sure what you're asking me, but like,
Because originally 2 to 8 is not negative.
well, it was. It just, I had to distribute because this piece was, the whole thing was negative. You know what I mean? Or no? It's okay. And at this point, we can clean this up. So I have 13 minus natural log of 12 plus the natural log of 4. And that's one of our log properties. Addition of two logs is the same as the product of their insides, which I hope is what I had written down on the answer key. Oh, good. So again, my goal was just using those two properties of logs, or two properties of integrals, to chunk this guy up into the pieces that I knew about, right? So I can take an integral and break it into the sum of parts just by like wherever the end of one integral is the start of the next integral. So the obvious place to chunk it at would be, you know, the 2, because that's what I know about. And then the integrals I needed to end with was -3 to 2 and then 8 to 2, because those are the ones that I need, right? And I needed to start with this one, 8 to -3. I think maybe on the key, did I do this? Did I flip this one and then link them together? Might have done it that way. That's fine too. Same difference. Ended up with the same answer either way. But it's just using those two properties. That's all you're doing. It's just kind of like shuffling the integrals around until the parts that you have are the stuff you know about and the stuff you want to know, and then it's just like some algebra. You know what I mean? And if you don't, we can talk about it some more, but like the horse is lying here on the side of the road and I just keep hitting it. It doesn't seem like it's breathing or anything at any point anymore. But I'm still just whacking away. I'm making a joke about like beating a dead horse. Yeah, okay. Not just horse abuse for the sake of itself, because it's funny, because it's not. Maybe it is. I don't know. You're laughing. All right. As this joke has thoroughly been Family Guide, right? Where you just keep going back to the same joke until it becomes funny, then it stops being funny, and it's like, is this still going? And then it turns funny again because you've just committed to it that long. Who's next? Taylor.
I have a question for homework.
Yeah, absolutely. We can do that.
Number 65.
In 5-5?
Yes.
Okay. Oh boy, what just happened there? You said 65, right? Okay. So this is the definite integral from 0 to a of x times the square root of x squared plus a squared, where a is greater than 0. Why are they giving this a is greater than 0 piece? Why did they specify that?
So that square root.
Well, you're squaring a anyway, so that's always going to be a positive.
Never mind. It's not.
It's so you know whether you have to negate the integral or not, right? Because if that's 0 to -3, then you're supposed to flip it, flip the bounds and make it negative. But if it's, right, and if it's 0 to 0, then it's 0. So you just had to like eliminate some of those kind of cases. That's all that a greater than 0 is doing. It's just telling you that you don't have to worry about, oh, the special case where a is negative, I get one answer. Oh, and then when a is 0, I get another answer. Oh, and then when a is positive, I get another answer. They're just saying, just do the one where it's positive. So this is a classic U substitution problem where you have one function inside of another. So x squared plus a squared is inside of the square root. So let's make that our u. The derivative of u then is going to be, with respect to x, is 2x. Where did the a go? It's a constant with respect to x, so its derivative is 0. So we don't, that just goes away. My leftovers then are x dx, so I want to get the right-hand side of that, our derivative, to be x dx. So I'll divide both sides by 2 and multiply by dx. So the integral from 0 to a is just u to the 1/2 du over 2, and I'm going to write the over 2 out front. Everybody's okay there? Now, I'm going to, this isn't quite right what I've written. What do I still need to do? I need to adjust my bounds. Or you could go back, you could leave your bounds the same and then substitute back in for your x's. That would be okay also. I'd rather do it this way. So the antiderivative of u to the 1/2 is 3 over 2 with a coefficient of 2/3. And we're evaluating that from a squared to 2a squared. So those can reduce. So I have 1/3 times 2a squared to the 3 over 2 minus 1/3 of a squared to the 3 over 2. So that's going to be, let's see, 2 square roots 2 over 3 a to the 3rd minus 1/3 a to the 3rd. So multiply the exponents to get the a to the 3rd. And then I also have a 2 to the 3 halves. That's 2 cubed, or 8 to the 1/2, or the square root of 8, which I just simplified to 2 root 2, which probably in the answer key they would write maybe even this way, would be my suspicion. Is that what the back of the book said? Let's look, right? I think we have, the back of the book is in there. Let me just pop that in. Odd Answers, Chapter 5. 65 is, oops, that was the review. Yeah, okay. So they wrote it as 1/3 2 root 2 minus 1 times a to the 3rd, which is basically the same thing as I wrote. I just put the 1/3 through as a denominator or whatever, but basically the same idea. I was right in thinking they were going to factor the a cubed out anyways. And how they wanted to write that last piece, I wasn't sure, but. Is that okay, Tay?
Yeah. What did you do when you switched the bounds?
So what I wanted to, so if I didn't do this step, when I get to here, I would need to do the additional step of plugging my expression for u back in and then evaluate using the old bounds, which you could do. That would be fine. But those bounds are for x, not for u. So you can either plug your bounds in as like a function of u. So I just plugged them into u. So like 0 squared plus a squared is a squared. And a squared plus a squared is 2a squared.
Okay.
So I can do that, and that gets me around having to substitute things back in. Or you can substitute things back in and use the old bounds. You'll get the same answer either way. I find that adjusting your bounds usually makes the arithmetic a little bit simpler. That's my preferred way to do it, but you don't have to. Does that feel good?
Yeah.
Okay. And that's a good one to ask about, right? Who's next? let's do this then for a minute, since nobody seems Johnny on the spot. So this is just the chapter 5 review from the text. We're just going to look at these integral problems here, 9 through 20, and then I'll scroll up and we'll look at the rest of them for up to 40. We're just going to say U sub or not. So all I want to do is just practice looking at them and tell if it's a U sub problem or not. 9.
No.
Good. 10. 11? No. 12?
Yes.
Yes.
Because of the exponent.
Because the exponent is around the whole thing. Exactly right. Or what could you do instead for number 12? You could use like the binomial expansion to multiply that out, which why would you want to do that? I would not. But it's possible to do it without U sub, but it's going to be real ugly. It's going to take you a long time to multiply it out unless you have the binomial theorem like down pat, which I'm guessing that probably we don't. Or you have a CAS calculator, which you ask it to just like do this for me. And Jackson's like, yep, I can do that. No. I mean, it's a 10-term polynomial, so yuck.
But then can you use that same calculator just to like plug everything in? Solve it?
And it's okay to use that on the AP exam. I looked it up.
Is it really?
Yeah.
Oh, wait,
How much is
what's
that?
this thing?
Yeah. It's probably in that 150 to 200 range.
Is that like worth the buy for like college?
If you're going to be taking like multiple calculus courses, it's an excellent tool to have just for like checking your homework.
So it's what
You can probably find a better number than 300, but
I think you said 150 is 300.
No, ours was 150.
Oh.
It's 149 on Amazon. Yeah.
Which one? This one or both?
if you get the Inspire CAS,
Inspired.
I think is what those guys have.
Yeah.
And then do I have to learn how to use a new
Yeah,
calculator?
A little bit.
Well, it's worth it. You need to add on.
It's true.
I think the old TI-89 was more user-friendly. Does the same, as far as you're concerned, it's going to do the same things. If you can find one of those, that's a good deal. Also has the computer algebra system on it, which again, if you like hit up the pawn shop, maybe you can find for a steal.
I don't know where I'm going to check this.
Okay, fair enough. Maybe it's a situation where they even selling it. Pawn shop has a website and selling it online. Buyer beware.
Maybe I can go to
But-
Pawn Stars.
There you go. All right, let's keep going then. 13. No, wouldn't use U sub on it. Just use your algebra. 14,
Yes.
or you could FOIL it out. Wouldn't be hard to do that either since it's only degree 2. But you could U sub it. Not unreasonable to FOIL it out though. 15.
Yes.
I would use U sub on this because I don't want to mess around with foiling out 5 of those things. But you could. Please don't. That's a nightmare. 16.
Yes.
That's classic U sub. There's no getting around that. 17.
Wait. Yes.
Yes.
Final answer, yes.
Yes, that's a U sub problem.
T minus 4.
T minus 4, and that's your U, so you'd be integrating U to the negative 2. Okay. Well, U is T minus 4, right? So your integral is going to be, when you do the substitution, 1 over U squared is U to the negative 2, right?
Is it squared?
That's a 2 down there.
Okay.
Yeah. Sorry, I tried to make it big. Do it need to be bigger?
So on the test, you're just gonna put evaluate the integral, and there's gonna be like a mix of like definite integrals and indefinite.
I'm going to have basically that all you're going to be asked on the test is like do a bunch of integrals a bunch of different ways, right? Like if I give you a graph that's gridded out, you're counting boxes.
Yeah.
If I give you a table of data, you're building Riemann sum. If you're giving like a curve with no grid behind it, you're going to like geometry it out. If you're given a problem like this, you're going to do it algebraically, right? Like it's all the test is, just like doing integrals.
And for definite integrals, when we use the u substitution,
You change the bounds.
You change bounds for the definite of u substitution.
Yes. Yes. Let's see, continuing on here. Where are we at? 18? Okay. Yeah, it's a U subber. 19.
Yes.
Yes. 20. 20.
No.
No, you're
What,
saying it.
what do you do, Victoria?
It's like, I don't know which one it is, but it's like the one that's like an inverse. You just do sine and then you do
No, look at the bounds.
Oh.
This is an odd function. Its integral is 0. Woof!
I love that.
Again, you can tell because it's odd, sine is odd, over 1, which is even, x squared, which is even. So it's an odd over an even, which is an odd function. Okay?
21 is 0. Because it's 0.
Correct. That's 0. It's an odd function. Again, your key to look for that is when the bounds are opposites like that. That's your key. Look for whether it's an odd or an even function. If it's an odd, it's a freebie, but you have to check to make sure it's odd. Again, tan to the fourth is even, t to the fourth is even, tan is odd, even times odd is odd, 2 is even, and cosine t is even plus even is even. Yeah. How about this one?
Yes.
That's a U subber. What are you going to make as your substitution?
Oh, it's just tricky. It's something weird. Because you're asking this.
I think you would want to do, yeah, let's think for a minute here. Well, if you do e to the x, what would you, yeah, that would work. Because then you end up with 1 over 1 plus u squared du. And then that's tan inverse.
That's where I'm at.
Yeah, that's a tricky one.
Which one is tricky?
Well, 22, picking what your u is,
Oh.
should be e to the x. Or e to the t or whatever. X is the variable.
Like from the denominator or the?
Yeah, so your denominator would be 1 plus u squared. And then the numerator, when you do the derivative of u, it's e to the x dx, which is your numerator. Yeah, that one's sneaky. 23.
Yeah. Do it.
What would you pick as your sub?
X. X over X.
How do you do that integral, though?
Never mind.
Just 1 minus
Just X.
No, you're right. It's 1 minus x over x is what you should pick. How do you do that, though? You write it as 1 over x minus x over x, which is just 1. Right? Since the denominator is a monomial, you can break the fraction into 2 fractions, and then it's easy. You saw it. About 24.
Nah.
You should.
Oh wait, because that's it. Because you can't. Never mind.
If it was the reciprocal.
Because I tried to subtract.
I knew that.
That
was the only problem.
I missed this one.
Okay, what would you pick?
I'm trying to get better.
What would you pick for your u on 24? X squared minus 4. the whole denominator.
Why?
Because you have u squared minus 4. 1 over u squared minus 4 is an antiderivative that you know. Minus 4. You do not have that as an integral, right? As an antiderivative, we don't know what that is. That's why I'm picking that whole x squared minus 4.
It would be du over 2 is equal to x dx.
Which again, you have the x dx as your leftover, so that looks good. How about this, 25?
Oh, x squared plus 4.
Good.
If I remember right.
Yep, that should work. And then you'll have to do some, the derivative of that is 2x plus 4, and you divide that by 2 to get the x plus 2, which is what you need, so that's a little sneaky. 26.
I want plus
Can you not give us this one? I don't know.
Yeah, isn't that
Yeah, like as soon as like
the derivative of
that's good.
cotangent is
Yeah,
it's over.
As we go on to cosine sine,
What is
In
it?
tangent is
even
over.
that's pushing.
Well, the derivative of cotangent is negative
Negative.
cosecant squared. So picking 1 plus cotangent as your u would be the good choice. About 27.
Oh,
I don't know why.
oh.
Oh, right.
Wait. I, no.
You could pick either sine pi t or cosine pi t. Either one would work. Because when you take the derivative of sine, you get cosine. When you take the derivative of cosine, you get negative sine. And now there's going to be an extra factor of pi rattling around because you got to chain rule the derivative. But that's okay. That's just a constant. Ooh. Derivative of the outside times the derivative of the inside. 28. Good. Cosine x should be your u. That's pretty straightforward from there. How about this guy?
What's in the?
That's e to the root x.
Okay, so I'm gonna go with root x because that's gonna be u.
Yeah, that would, yeah. U should be root x because the derivative of root x is 1/2 times net root x to the negative 1, or 1 over root x,
Yeah.
which is the leftovers there. That's good. 30.
U is equal to
U should be the natural log of x because the derivative of the natural log is 1 over x. Yep. How about 31?
Like cosine. Good answer.
Natural log of cosine x.
but then tangent would have to be sine over cosine.
So if you did that, I think Jillian's right, because the derivative of the natural log of cosine is going to be 1 over cosine times sine, which is tangent. Yeah, so that one's nice. That was maybe not obvious that that's going to be the choice because you're not picking the inner function.
Test us on this trick. I know. I'm gonna forget.
Yeah, no, I don't.
Like I need someone to like really beat it in my brain. I know everyone's gonna hate me. You can just give the quiz to me.
32.
I would fail that harder than
Huh?
That's true. If you get 100,
Sure,
you
your
get 3
identity
points
is-
extra credit on your test.
I don't think that's going to work.
No.
This is
I think
tricky.
you look at yeah.
Right?
X.
Very tricky.
I'm feeling something. There's not brewing inside.
It's not 1 minus x squared. It's not 1 minus x.
Why can't it be 1 minus x?
X to the third.
What?
1 minus x to the third.
No. What did you ask, Luke?
Why can't it be 1 minus x squared?
Well,
As your
where would 1 minus x, so then you'd have u times 1 plus x squared, and then x. What's going to be, how are you going to get rid of the 1 plus x squared part?
Well, there's a trick to this one. It's
U should be x squared.
What? Oh, because
Because 1 over the square root of 1 minus x squared is one of the trig inverse antiderivatives.
Are we gonna
I can't regurgitate
Am
that.
I gonna need to know like every trig identity for this test?
if you're
No, but you do need to know all your derivative rules for the test, or antiderivative rules.
Okay, like just the ones in like the book.
Yeah, like the ones in the
Like
book.
10? Okay. Okay, I have flash.
Like, look at this. That was what we were using. That's what we needed, was 1 over square root 1 minus x squared is sine inverse.
Oh, I knew that one.
That one was not on my flashcards, I'm not gonna lie.
So that's again, if you didn't remember that, super tricky one, right? We gave you guys lots of chances, nobody came up with it. That's okay. Some of these are quite difficult. 33. This one's a little bit easier to see, I think. X squared again. How are you going to get we have an x cubed up here. What are you going to end up doing?
Sub back in for x.
Yeah, you're going to have to sub back in for an x, which stinkies. But you'll end up with square root u, right? If x squared is equal to u, then x, 1x is no, wait a minute. No, that's bad juju. No, we're not right. You want to pick 1 plus x to the fourth, because the derivative of that is just 4x cubed. And then you're good. Yeah, that's a sneaky one there. Yes, sir.
Do you mind explaining the choice of u for 23 again?
23?
Yeah.
Every single one of this.
Yeah, we just picked the insides.
Yeah.
You just have to write as 1 over x minus 1.
1 over, okay.
Because since the denominator is a monomial, you can break this into 2 fractions with a common denominator. And then the derivative's easy to do, because it just,
This might be the first test that like failed.
I think, oh boy, what is going on there? 34 we wouldn't ask you to do because it's got hyperbolics in it. Not an AP question. We're not doing anything with hyperbolic trig functions. How about 35?
Double and give it to the next person.
I see a quote.
35.
Yeah.
Okay. So the derivative of secant is secant tan.
Mm-hmm.
So then you would just do secant.
1 plus
1
secant.
plus secant because it's 0.
Yeah, because the derivative of 1 is 0. Good job.
Scientist.
It really helps to have those memorized, guys.
Can you believe, you know who Blake is?
Bortles? Banninger.
Manager.
Yeah, he knows what it is.
Yes.
He was like, you're in calc? I was like, yeah. He was like, wow, congrats. Because he thought it was stupid. Like, that.
Okay, he does that to everyone.
Yeah, he does that to me. He did that to me, but like he was kind of right. So.
Just tell them what you got on the exam.
Yeah, I don't know how I got that.
He doesn't understand.
Well, it's because you know everything you're supposed to know. That's how it happened.
It's just literally.
Like you did well because you've worked really hard and you have everything memorized that needs to be memorized.
Yeah.
Mr. Kulik, last year you doubted me taking this class.
You're doing great.
Because I
I think you're doing great. All right. Does everybody feel okay? You feel a little bit better about picking our U's and deciding whether something's U sub or not?
No, but I'll figure it out. I always
All right.
do. I always do something.
You do, Sergio. You do.
Wait, whoa. For 36, isn't secant squared just 1 plus tangent squared?
Yes.
So would you pick that as your U?
I would pick 1 plus tan t as my U, because the derivative of tangent is secant squared.
It says this is forward vulnerable.
And then it's not too bad. How would you do like 37 or 38 where you have the absolute value?
Oh, doesn't something? We can absolute.
Well, no, but this is something that I've seen show up many times on the AP exam.
What if you like 1 over all that stuff?
So let's grab 37 there just for an example. And I'm going to drop it in and just kind of show you what to do with that. Because these are good ones, because they're not obvious really what to do. Do we have an antiderivative rule for the absolute value? No. So go back to Algebra 1 and tell me what's the definition of an absolute value.
It makes things
Positive, yeah. It can't be.
or that. Like that's the fancier way of it.
I mean, you got an idea.
Right?
Either way.
So if I look at the graph of x squared minus 4, what does that look like?
So it's going to be.
It's a parabola.
Up or down,
And which way does it open, up or down? Up. What are the x-intercepts?
0, or no, 4, no, negative 4, 0.
I mean negative 2, 0,
Yeah, wait.
and
2, 0, and
positive 2, 0.
Yeah.
Yeah.
See it, I just couldn't say it.
So you have, if we're going from 0 to 3, you have those two areas, right? Everybody agree with that? So we're going to integrate from 0 to 2 of negative x squared minus 4 dx. Since it's an absolute value, it's like we've bumped that part above the x-axis.
Wouldn't it be like,
This part, I mean. Right? Sorry. So it's like, pick another color. Right, so we're doing that part. So by making it negative, I'm getting a positive area. And then we would do plus integral from 2 to 3. So we get rid of the absolute value by taking the parts, you're breaking your integral into parts. The part that's below the x-axis, you negate those parts. The parts that are above the x-axis, you just leave them the way they are. And then you can go from there. Sneaky!
At least it makes sense.
Yeah.
Like I don't know if I can do that.
Well, it's one of those that, like, once you've done a couple, it's okay. Recognizing it's the hard part. When you see the problem and you know what, and knowing what to do. That's the hardest part. For the most part, like, you guys are good enough that if I tell you what to do, you can do it. It's about, the hard part is recognizing it on your own and knowing what to do with it, right? Would I put something that difficult on the test coming?
For extra credit.
No, I wouldn't put it on there. But that's like a question that I have seen, like things similar to that pop up on the AP exams. So just like recognizing how do I deal with the absolute value of something with doing an integral.
It's not hard.
Experience, social analysis.
What's the last one?
You guys got anything else that you guys want to talk about here? We got like 15 minutes or so left. If there's some more stuff that you guys want to talk about, or just in general.
How did the other class do?
Pretty well. Pretty well.
What did Robert
Huh?
No curve.
Yeah, can you tell me the exact scores of people?
And no, but I think that like everybody finished inside of the class period, which I was excited about.
Hey!
I still think that.
Like it didn't seem like, in fact, I think the first person was done in like 40 minutes or something. So
Was it as many problems as the review?
it was pretty similar in length. Probably a couple less, but like close enough. But lots of A's. Not surprising in a course like this. Like I think it's pretty doable to do well. The most common mistakes were like reading related. Where like you saw the picture and you didn't read what it was asking for from the picture, and like you did too much or something. Like that kind of thing where it's like, oh yeah, you did like this integral when I asked for this integral, so you did counted too many boxes or whatever. Which
that's tricky. You're gonna put this big graph and then be like, oh, you only need like from this to this. Everyone's gonna think, oh, I'm going from this to this.
yeah,
You're
for
preying
sure.
on those people that don't read and just go.
Look, kind of. So yeah, I mean, those are the most common mistakes. Were like silly things, like the people that no one got 100, but the reason they didn't get hundreds is because they didn't. Stuff like that, or like screwed up the like was drawing, on a problem like this one, like drew down and didn't like draw straight and estimated the point wrong or something. Just like silly stuff, But, I thought in general, like if you knew it, you did really, really well. If you didn't, you still did pretty good because the parts that like were a little shaky, there's lots of stuff in there to kind of buoy that, like the Riemann sum stuff should be pretty easy even if you're kind of shaky on the U sub parts and like, or like.
I forgot everything we did.
Well, it's because you didn't have to take the final, which like
I'm saying the beginning of like this chapter.
Oh,
I have like the
okay.
memory of like a fish.
Oh, okay. That's rough for a test that there's no equation sheet for it. Like on the fine or the AP exam where it's like, oh yeah, here's your equation sheet. Nothing.
But like, I mean, it's not that bad. A lot of people. I think most people got one. Like a lot of people got one. Yeah, like average school.
Here's again, all of that. Maybe be honest here. Like, if you get a 1 on the AP exam, it's because you quit.
Okay.
If you've sat in the class the entire year and you take the AP exam and you get a 1, it's because you quit. You're reading the questions or whatever, and you're like, I quit. You're like, this is hard. I'm not sure what to do. I feel like I'm failing, which is normal. That's probably in like you're heading towards like 3 territory if you feel like you're failing. And because again, like
I just need to learn how to like read the question and know what it's asking. If that makes sense.
Yeah.
Because even during the
But if you really just like fill out the test,
Because
it
remember,
puts
like,
you ahead of like 30% of people.
look, there's 108 total points. 59 out of 108 is a 4.
That's pretty good.
Okay.
59 out of 108.
Alright, I can get
So
Yeah.
you can be doing really, really well, and it'll feel like failing.
Okay, so
And that's okay. What's problem is you get to the end and you're seniors and you're burnt out and it's like your 4th big test you've been trying to take, and you get like through one section of it and like, well, I just failed that section, and you quit. And you don't do anything.
Are the IB tests before or after the AP test?
I don't know what the schedule looks like.
I have two pretty big. tests.
But that's what happens. Because look at where the 1 is. 27 points.
Okay, so like.
That's literally like you did like 1 or 2 multiple choice sections. You didn't do any of the free response, and you just quit. And that's okay. It happens. I get it, but that's how you get 1s. And when you say, "Oh, most people got 1s," it's like, well, then just most people just quit. They got to the end and they're like, "I didn't want to study for this." And rather than trying and feeling like, "Oh, I tried and got like a 2 or a 3," which I'm going to feel upset about that I tried and that happened. I'm not going to try and get a 1. And then I can just say, well, I didn't try. I could have gotten a 4 or 5. Like it's a gutless move, right? It's like, oh, I could have tried and then gotten a 4 or 5. It's like, well, why didn't you just try then? If you could have done that, right? Like just try.
Well, I'm not saying I'm not gonna try.
No, I'm just, but I'm like,
Yeah.
it's a really easy like mentality to slip
Right.
into at that point. in
No,
the
I don't know
year.
if I'm gonna be like studying for like.
No, and again, like, here's the thing, like, 59, 4,
Yeah. Yeah. That's fair.
59 out of 108 is a 4, right? Like,
Did they let you know if you get a perfect score?
I don't know.
No.
I heard they used to do that.
So like, again, it can be going real bad, but if you like nail a section, makes it pretty reasonable to get a 59.
The only issue is.
If you just don't zero out.
So it's like.
But here's the thing, it's also for you. Because you're not taking this class if there's not a chance you're going to end up having to do it again in college.
Yeah, no, I'm for sure gonna have to take this.
And I promise you, if you try on the exam, even if you don't study that much beforehand, that's learning. Learning is happening, and it's real learning, and it's good, and it's valuable, and it carries through. Like, it is to your benefit to try.
Yeah.
Even if you didn't study that hard for it, but like getting to the exam and like trying to finish the sections and like doing real math and not just like drawing a picture or like filling in random bubbles. Like thinking about it with what you have available to you and trying. Yeah.
Could we do like more AP like practice? Like my biggest problem with that is just like when I read some of the AP questions, I don't know what they're asking because I've never seen that type of thing.
The hope is, my goal is that like the last like 2 weeks of class, that's all we're gonna do. It's just like once we've gotten through the content, and I can just like willy-nilly hand you something and just be like, look, we're just gonna do the multiple choice section part, calculator part in class today. And then like we'll go through and I'll burn through the answers and we talk about stuff that you weren't sure about.
Oh yeah, that's a good question.
And then like, or I'll assign like, hey, here's a free response section. Do this as your homework. We'll come in the next day and talk about it. And like that's the plan. But like, because especially the free response stuff, it's all the topics kind of mixed together. It's really hard to pull like a free response question, be like, here, do this right now, where it's like we have barely done integration, like we haven't done, like it's not so narrow, and I'm trying to get multiple choice stuff like in there. If you want that, I can post like some stuff that you can just do.
I don't.
Sure. I think I have one that I've. Let me do this.
It's like,
Yeah, hey, what's that supposed to be?
I'm pretty sure he's spoken.
I'm calling Michigan.
It probably would.
No, but it could be spoken at home and I could just like not ever learn Spanish. Because there's a lot of like.
Oh, yeah,
foreigners
that's
who
fine.
are Spanish, like they don't know Spanish. It's like weird.
That is strange.
Like, some-
Okay, sure.
I said to speak
I think if I don't put a due date on there, can I do that? And it's just like permanent?
No.
There.
But like, why are you telling me to speak?
So if you go now, Luke, for example, I just have like chapter 5 practice problems, and there's a lot of those. There's like 20 or 25 of them or something in there. Again, do them or not, that's fine. Oh, what's up?
Substitution, isn't that a BC topic?
Integration by parts is a BC topic.
Is that where you like double use up?
No. Integration by parts is like is using the product rule backwards. That's one of the BC topics that I am going to do, because it's like if you take.
Yeah, my brother was. I was thinking at something. My brother was like, "Oh, I would use integration by parts, but I don't think you do that." I must have mistaken that for use substitution.
Yeah. Here.
Okay.
So this is the idea, right? Like this is Paul. This is the product rule, right?
Yeah.
So that means if I integrate both sides, this integral, which is just f of x, g of x, should equal the integral of that stuff, right?
That looks scary. Oh, that's just
No, it always looks scary, and then the guy online does it.
That's not scary.
And I can distribute the integral out, right?
Yeah.
And then I can like subtract this integral to the other side, right?
Yeah.
So I can just say this integral is equal to this times this minus this integral. That's integration by parts. Now usually write it with u's and v's, but that's the formula. That's all it is. The trick is figuring out what u and v need to be, or really what u and dv need to be. But that's the idea. It's just
We're learning that.
that's a chapter 7 topic. We're gonna do all of 6 before we'll do that one section of 7.
Is it just one section?
Yeah, I'm just doing one section of 7. Well, some of these other things are.
You should make that a test.
Some of these other 7 topics are good ones too, but I want to do the chapter 9 stuff, which is AB questions. These are not AB questions. These are BC questions. Well, this is BC. This is BC, 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 BC.
Oh, so we just have chapter 6 and chapter 9.
Yeah.
Technically.
Yeah.
Because I was like, are we gonna try to like cram all that? Like we're running out of time.
And this is it. These are all the topics that I would like to do, and some of them that are BC topics, depending on how much time we have at the end, we might not do.
Yeah, that's what I'm thinking.
You know. So, Sergio, what's up?
Well, this class basically just be like a read. Like if I take calc 1 in college, we'll just basically just get a read.
I don't think you'd get as far as this is like, I would say like 1.5 is what I would consider. AP Calc is like Calc 1.5.
Oh, so I'll be even more. Okay, that's good.
I saw a TikTok of like college kids doing calc and it was like,
There's like more than one calc.
There's more than one.
Yeah.
But I've heard.
Also, wait.
if you go to-
Also,
especially if you go to
if I don't know what I'm
I've heard you
doing,
want to enroll in Calc 2, not Calc 1.
What's up?
if I don't know what I'm doing, say I don't know how to do the integral. Can I just take the derivative
They
and
make
will I
it
get
harder
some
than
partial
it should
from
be,
it?
so that they try to get you out of school.
By taking the derivative of an
Yeah.
integral?
Like if I no, I'm saying like if there's like a
So like,
question like oh I
you
don't know how
want
to
to
do
be
the integral, can I just take the
anti-subject, you want to
derivative?
like, you want to
No.
enroll in the higher class.